Let's start with a big question. Is the reasoning we're seeing in today's most advanced AI actually real? Or is it all just a sophisticated illusion? A kind of magic trick that looks a whole lot like thinking, but is actually something else entirely.
Okay, take a look at this. This is a real response from an AI. It's asked a pretty simple question. Was the US established in a leap year? And it starts off great. It correctly states the rule. It figures out that 1776 times is a leap year. But then it concludes the exact opposite. It's a leap year. Therefore, it's a normal year. Wait, what? How on earth does that happen?
I mean, what is going on inside the machine here? This isn't just some random bug. The researchers who found this argue it's actually a massive clue, a breadcrumb that leads us to a much, much deeper question about how these large language models actually think.
And that brings us to this concept the researchers call the illusion of reasoning.
So at the very heart of this whole debate is a technique you've probably heard of called chain of thought prompting. The idea is pretty simple. You just add a little phrase like, "let's think step by step," to your prompt. And when you do that, the AI lays out what looks like a perfectly logical sequence of thoughts before it gives you the final answer. It really seems like it's reasoning, just like a person would.
And honestly, it's so easy to see why this is so convincing. When it works, the whole process is seamless. You give the AI a problem, you give it that little cue, and boom, it lays out its premises, it connects them, and it comes to the right conclusion. It really does feel like you're watching a mind at work.
But what if it's not a mind at all? What if it's more like a mirror? Well, a group of researchers at Arizona State University decided to come up with a new way to find out for sure.
So here's their core idea, their big hypothesis. The AI isn't actually thinking, it's mimicking. What we see as logical reasoning is just incredibly advanced pattern matching. The AI isn't coming up with new conclusions on its own, it's just spitting out text that is statistically similar to all the reasoning examples it saw in its training data.
So this is the absolute key difference, right? True reasoning versus just pattern matching. Think about it like this. Imagine a student who actually understands physics versus another student who just memorized the answers to last year's exam. The first student, they can solve new, tricky problems because they get the underlying principles. But that second student, they're perfect on the questions they've seen before, but you give them a slight variation, something they haven't seen, and they just completely fall apart. The researchers are basically arguing that today's AI is that second student.
So, to really put this theory to the test, they designed a brilliant experiment to push the AI way outside of its comfort zone. They decided they were going to probe its abilities across 3 key areas: the type of task it was asked to do, the length of the reasoning required, and even the format of the question itself. Now, to do this right, they couldn't just use an off-the-shelf model. They needed a special kind of lab, a custom-built AI proving ground. They called it DataAlchemy, and you can almost think of it like a forensics lab for AI. By training smaller models completely from scratch on their own carefully designed synthetic data, they could have total control over what the AI learned. And that meant they could then systematically see exactly how and when it failed when it was shown something new. Okay, so the first test was all about the task. Could the model handle a new kind of logical problem it had never ever seen before? Or what about just a new combination of operations it already knew? This is just like asking our memorizing student a question that mixes ideas from 2 different chapters of the textbook. Next up was length. So, if an AI was only ever trained on problems that took, let's say, exactly 4 steps to solve, could it figure out how to solve a similar problem that needed 5 steps? Or maybe 3? If it's really reasoning, that should be a piece of cake, right? And finally, there was the format test. What happens if you take a problem the AI absolutely knows how to solve, and you just rephrase the question a little bit? Does its underlying logical abilities still hold up, or is it so attached to the exact wording that it gets completely thrown off? So what did they find in their lab? Well, the results, they weren't just interesting, they were absolutely stark. This is the exact moment when the Mirage just vanishes. On problems that were structured exactly like its training data, what's known as in distribution, the AI was flawless, a perfect 100% score. But the second it was given problems that were even a little bit different from what it had seen before, out of distribution, its accuracy completely fell off a cliff. We're talking plummeting to almost 0. Looking at the hard data from their paper is even more shocking. Look at this, a perfect 100% on the tasks it was trained for. But give it a new combination of tasks it already knew, the accuracy just craters to 1/100%. And for truly new, out-of-distribution tasks, zero, nothing. A complete and total failure to generalize. And they saw the exact same failure with length. The model was trained only on 4-step problems, and it got 100%. But ask it to solve a 3-step version or a 5-step version. 0% accuracy. It literally could not deviate from the exact pattern it had memorized.
The researchers' own conclusion really says it all. I mean, they wrote, "Caught reasoning is a brittle mirage that vanishes when it is pushed beyond training distributions." Wow, they're not pulling any punches there.
So what does this all mean for us, for people actually using these tools? Well, it means this apparent brilliance is incredibly brittle. Probably the best way to think about it is this. The AI's reasoning is like a perfect but very fragile recording. It can play back the patterns it has learned with flawless fluency, but the moment the music changes, it just can't improvise. It doesn't understand the underlying music theory. It only knows the one song it was taught to play. So the paper gives some really practical advice based on all this. We have to be careful not to over-rely on these very convincing chains of thought. We need to prioritize testing AI on data it's never seen before. And at the end of the day, we just have to remember this one key lesson. A fluent, well-written output does not mean there's true understanding underneath. And that, right there, is probably the most critical takeaway for all of us, that fluency can be incredibly deceptive. Just because an AI can write out a beautiful step-by-step explanation that sounds totally logical, it can still be completely fundamentally wrong, just like that leap year example we started with. That convincing performance is very often just a replay of patterns, not a real demonstration of understanding. Now look, this research doesn't mean these tools aren't powerful. They are. But it does force all of us to face a much deeper, more profound question. If the AI isn't really reasoning in the way humans do, then what exactly is it that we're building? And what does it mean for us to rely on a mind that might not be a mind at all?